Students, myself Punnam working as an assistant professor in Mlritm, Dundigal branch. So I'm going to teach you the subject called control system. So this course is introduced for third year triple E for first semester course. The syllabus of a control system is Unit 1 is Introduction to the Control System. It consisting of classification of control system, feedback characteristics, effect of feedback, mathematical modeling of a electrical and mechanical system, and basic concept of a transfer function of a potentiometer, synchros, AC servo motor and DC servo motor, block diagram reduction of a techniques and signal flow graph and using by mass and gain formula. So in this course, the student can able to learn the control action of a action of a industries using a different control methods, and he can also learn the stability of a system. So next unit is time response analysis or time domain analysis. In this chapter, the student can able to learn the standard test signals and time response of a first order system, time response of a second order system, and transient response of a second order system for unit step input and various test signals, and time domain specifications like rise time, peak time, delay time, and peak overshoot. And he can also learn the steady state error and steady state response of a various signals. And third unit is stability analysis in S domain. The concept of stability by using Routh-Hurwitz criteria, and the student can able to learn the absolute stability, relative stability, limitation of a Routh-Hurwitz. And in the third unit, also the student can able to learn the root locus technique, the root locus concept, construction of a root loci, effect of adding a pole and effect of adding a zero to a root locus. And fourth unit, the student can able to learn the frequency response analysis. In this chapter, the introduction of a frequency response, frequency domain specifications, Bode plot, stability analysis from the Bode plot, and the determination of transfer function from the Bode plot and polar plot. The Nyquist plot, also stability analysis using gain margin, phase margin concept. And also student can able to learn the introduction of a lag lead and lag lead compensator designs. And last topic of the control system is a state space analysis. The concept of state space and state variable and state models, derivation of a state models of a linear time invariant system, controllability, observability, and diagonal state models, and state transition matrix, and solution of a state equation, concept of controllability and observability. The course outcome of a control system subject is develop the ability of a modeling linear time invariant system using transfer functions, analyzing a system behavior in the Laplace domain, analysis the stability of a LTI system in the both the time and frequency domain for a reliable and stable operation of a control system, understand the concept of system stability and the assessment using Routh stability criteria and root locus, evaluate the stability, transient response, and steady state response behavior of a system using tools such as transfer function, Nyquist plot, Bode plot, and compensators, and also analyze the modeling of a linear time invariant systems using the state space representation. The presentation outline of the first course, control system course, is introduction to the system and difference between the system and control system, concept of control system, and different examples of control system, and classification of control system. So what is control system? So control system, a system which consists of a number of components are connected together to perform a specific task. or function in which the output is controlled by its input. So for example, this is a control block, this is a system. For this, the input is applied at the point here, and we are expected to get the output here. So suppose this block is, suppose let us consider this control system, or the object is, let us consider a steam flow in a steam thermal power station. So suppose I want to control a steam flow of a thermal power station to a turbine. So I have to use a speed governing valves, and this is a turbine, and this is the main steam line. So this steam will flow like this through a governing valve. We will supply the steam to the turbine. So the steam from the main steam line, the steam pressure may be a 13.8 megapascal. This steam is applied to a turbine blades, then the blades of a turbine start rotate, and the output is mechanical energy. So the blades of a turbines start rotates, and then the shaft of a turbine also rotates with a certain speed. Slowly it will increase from initial point 0 to 3000 rpm, and this speed is controlled by using these governing valves. So here the controlling action takes place by using the speed governing valves. Similarly, let us consider a temperature control of a boiler. This is a boiler, and from the various corners we are inserting a RTDs, which is used to measure the temperature of a boiler continuously, and this information is sent to a control room. So suppose the required temperature for generating a steam pressure to 13.8 megapascal is, let us take 530 degrees. 530 degrees. So once the required temperature is reached, then we have to control the boiler temperature by feeding the coal to the boiler. So we have to reduce the coal flow. This is another example of a control action in a thermal power station. And similarly, if I want to reduce the speed of a induction motor, I can use a different methods: frequency control method, voltage control method, and triple VF method. Different methods are there to control the speed of a induction motor. So this control technology is used in all the electrical equipments as well as mechanical system side, everywhere in the day-to-day life. Next. So the difference between the system and control system. So difference between the system and control system is, suppose this is a system, and for this the example the input is applied here, and I am getting the output over here, and which is may not be a desired output. But in case of control system, the output is compulsory, it is a desired one. So whatever input I am giving, if I expected to get my controlled or desired output, I have to add some control element over here. From getting this control element will get the information from the output of a system by using a feedback concept. So few more examples of a system and control systems are: a fan without blades cannot be a system because it cannot provide a desired or proper output or airflow. So you can visualize the picture of the fan without blades. And fan can be a system. Fan can be a system with a proper output. The fan with blades and without regulator can be a system because it can be provided a proper control. For example, airflow, that is airflow. But it cannot be a control system because it cannot provide a desired output, that is controlled airflow. So I am considering this fan, which is the input for the fan is 230 volts, 50 Hz AC supply, and I am expected to get the output of a system is airflow, proper output, that is airflow. And if I connect the regulator to the fan, it will be controlled. If I won't connect the regulator to a fan, it is a uncontrolled flow of air. So see, for example, for control action, the fan with blades and with a regulator can be a controlled system because it can be provided a desired output, that is a controlled airflow. So observe here, this is a fan which is having an input of 230 volts, 50 Hz AC supply. I am connecting this to a regulator. Through the regulator, I am connecting the supply to a fan armature. So once the switched on, the fan is able to start, and the speed of a fan can be controlled by using this regulator. Now, the classification of control system. The classification of control systems are depending of the control action. One is open loop control system and another one is closed loop control system. For example, let me consider a black I am applying certain input to it. I will get some output. Okay, so this output may be or may not be a desired output. If I connect a feedback over here, to a input, then I can able to see the output exact situation. Depends upon the desired output, I can add one element which is called as regulator. In the above example, I can increase the regulator fan speed by increasing the regulator position. I can decrease the fan speed using decreasing the position of a regulator. So the control action must be having a feedback. Without feedback, the output is not desired. So classification of control system, the definition of an open loop control system is a system in which the control action is totally independent of the output is called as open loop control system. See here, the reference input is applied to a controller. The controller gives some control input to a plant or a process with a certain disturbance. The output may be or may not be a desired. So this kind of setup is called as open loop control system black diagram. For example, the traffic lights, fan, bread tester, normal iron box, electric hand dryer, washing machine, etc. These are the uncontrolled or open loop control system examples. So examples of a open loop control system, as I said now, electrical hand dryer, hot air output comes out as a long as you keep your hand under the machine, irrespective of how much your hand is dried. So automatically washing machine, this is the machine running according to the present set time, irrespective of washing is completed or not. So these are the few examples for the open loop control system. Next, closed loop system. As I said that a closed loop system must connected with a certain feedback network. The output has an effect on control action through a feedback as the shown on, and hence the closed loop control system or feedback control system. Other words, the control action is totally depends on its output. In this system, in this black diagram, you can able to see this is my reference input. I am applying this reference input through a summing point to a controller. So the controller will generate certain output, and controlled output input is applied to a plant or process, and the desired output will be generated. For suppose the desired output is, let us consider a 230 volts is my desired output for this block diagram, but I am not getting 230 volts here. I am getting, instead of 230, I am getting 220 volts. Okay, so this 220 volts feedback will be sent to a summing point or reference input, and then the error signal will be generated, and this error signal is connected to a controller action. So controller will decide and generate a signal or increase the voltage level by 10 volts, and it will give certain inputs to the plant or a processor, and my desired output will be generated. So the feedback is having a major role in a closed loop control system. As I said earlier, the thermal power station, for suppose the steam pressure is maintained is 13.8 megapascal, but originally I am getting a steam's pressure is a 13 megapascal. So I have to increase the pressure of a steam. I want to increase, or I have to increase the pressure of a steam from 13.0 to 13.8. So this feedback signal will generate the error signal by comparing with the reference input, and this error signal will be given a command to a controller. So controller will decide how much pressure I have to increase, how much pressure I have to decrease, and then the controller will decide to give a command to a boiler temperature. They has to increase a boiler temperature, so that if the temperature of a boiler increases, the plant or a processor pressure will increases, and the desired pressure will be maintained at the main steam line. So this is the closed loop control system example. The example of a closed loop control system. So human being, so we are a complex control system actually. If a person wants to reach the book on a table, the closed loop control system can be shown in figure. So see here. So my reference input is a position of a book. My reference input is position of a book. My eyes are the feedback elements, and brain is a controller, and hands are the process or a plant. So a desired output is I want to reach the position of a book. I want to take that book, position of hands, and I have to take that book in my hand. So but I am unable to take it. So the eyes will see eyes are seeing the book on the table, and that signal is compared with the reference input, and the error signal will be generated, and this will be analyzed by the brain, and brain will take a necessary action and give a controlled input to the hands. Then hands will try to hold it. So this is one more example for a closed loop control system. So a difference between open loop and closed loop system. So difference between the open loop and closed loop system is, a open loop system is a simple and economical because there is no involvement in a feedback system. So for the feedback we have to spend more. So in that situation, in case of open loop control system, there is no need of feedback. So it is a simple and economical. And closed loop system, complex and expensive. And second difference is easy to construction because it requires less components. It requires a less component. Not that much easy to construct because it requires more components such as feedback components. So as I said that there is a no feedback in a open loop system and there is a feedback in a closed loop system. Consumes a less power. Open loop system may consume a less power compared to the closed loop. And inaccurate or unreliable output will be generated in an open loop control system. In case of closed loop system, the accurate and reliable output will be generated. Generally, the open loop systems are stable. Stability is the major problem in the closed loop system. And difference between the open loop and closed loop. Next difference. The small band width in case of open loop system and closed loop system, in case of closed loop system, large band width. Output measurement is not required, but output measurement is required by using feedback link. The more affected by the noise or disturbance in case of open loop system, and it is less affected by the noise or disturbances. The output variation cannot be corrected, but in case of closed loop system, the output variation are corrected automatically. An example for the open loop control systems are coffee maker, automatic roaster, normal iron box, fans, microwaves, microwave, etc. etc. And for the closed loop control system are human brain or human being, automatic iron box and air conditioner, servo, voltage stabilizer and guided missile, etc. So these are the few differences of open loop and closed loop control system. Thank you.